For those of you who don't know who I am or who Gait in Motion Technology is, just going to start with a quick introduction. Myself and Scott Barton founded the company in 2018, and previously we both worked with pressure measurement technology and traditional orthotics, and then we retained the pressure measurement technology and founded GMT in 2018 to pioneer FITS 3D printed orthotics in the UK and Ireland. We work quite vastly in the clinical world, so predominantly most of our time is spent helping people like yourselves in private healthcare, whether that's podiatry, physio, etc. And we provide various technologies to enable them to improve their MSK and biomechanics service. We are most known for the foot scan technology that you can see in these pictures, which we've got at the show today. We're also quite heavily involved in research. Our technology is in 80% of UK universities, and that spans from pressure measurement all the way up to full gait labs at the top end with motion capture, EMG, force place, etc. And over the last couple of years, we've been giving back quite a lot into education. So we do quite a lot of teaching and lectures, places like Salford, Plymouth, etc. We'll be providing workshops to final year students just to open their eyes really to the world of podiatry and what's possible when you move on. Favourite area that we work in for myself is elite sport. So we provide the technologies into Premier League football, F1, England cricket, rugby, etc. All with a view of injury prevention and performance enhancement really. And I've been fortunate enough to work with several British and world champion athletes over the last few years, all with a view of gait analysis and 3D printed orthotic intervention as well. So we've worked with several major brands like Nike, etc. In terms of footwear development as well, which is another area that we use the pressure measurement technology. A few years ago, off the growth of our national network, we brought our national network together as one and called it Gait in Motion Clinics. These are all private independent practices. I know there's a few of you guys sitting here today that are in our network. The real goal of this is to raise awareness for what you guys do for the general public, and we reinvest quite heavily back into this. We've had an awful lot of national press over the last 3 years, really just to raise the profile of podiatry and what you guys do in the clinical world. Now, gait analysis traditionally, as we know, is quite a visual thing. We will often look at the way people walk, whether it's along the room, on a treadmill, and it is quite subjective. Of course, we've got our degree and our years of experience, but the reality is we can't actually see what does go on beneath the foot. So from a prescriptive point of view, there often then comes quite a bit of subjectivity in decision making. The most sort of common modification that we see in the orthotic world is rear foot posting. And again, if you were to go and ask multiple clinicians the same question about a patient, they would often give you different answers. And that's not a problem, but there is quite an area of subjectivity in that world. And same with the traditional process. In our old company, we're very much focused on casting and foam box, which is how it's always been done. And in recent years, that progressed to 3D scanning. We started off with big box scanners, which are quite expensive and bulky. It then progressed onto the structure sensors. And in the last year, we've now moved on to literally using a LiDAR camera on an iPhone to give you the static 3D shape. But all of those traditional processes are very static in nature. Typically, we get a shape of the foot along with our visual interpretation of what's going on. And we send that to a lab, and we hope what comes back matches up with what we're looking for to achieve that patient. And the traditional manufacturing processes that we used in the past as well, there is always an element of, I guess, guesswork in the handmade approach. My colleague James here managed our orthotic lab for 15 years. And again, there's lots of material waste with things like CAD/CAM. And yeah, you didn't always get what you order, unfortunately, in the traditional world, as I'm sure some of you appreciate, particularly when you ask for a second pair. And traditional devices tend to be either polypropylene, so plastic, EVA, or carbon, which typically are one density throughout. Yes, they can be the shape of the foot and we can apply certain modifications, but they are quite restricted in their nature in the current day in terms of new possibilities that 3D printing has opened up. And some of the more softer heat-molded devices are certainly great for a short-term intervention, but they tend to lose their prescription quite early on. And again, very much based on that static foot shape approach. Really positive to see more and more companies transitioning to 3D print in recent years. When I spoke at the first Foot and Ankle show, we were the only company here doing the 3D print, and I've already seen 4 or 5 companies now, so it's great to see that transition on the market. Now, there's lots of different types of 3D printing. One that most people are aware of is called FDM, where you have like a little box 3D printer, sits on the side, and it gives you a layer over layer over layer. And it's okay, it's quite a low-end option. It's not hugely scalable in that respect. And the device, from a longevity quality point of view, again, is not necessarily as long-lasting, and they're also quite difficult to modify as well. So our devices that we work with are called SLS, selective laser sintering. Our 3D printers cost £800,000. They are monsters, as you can see on the picture here. But they can print 55 pairs at a time. So from a global scalability point of view, that's really helped us to expand over the last 5 years. And as you can see from an intricacy point of view, with SLS printing, there's a lot you can do with them. We really try and make these look the Ferrari of orthotics in terms of what's possible. This is our headquarters at Materialise, so we are fortunate to be partnered with the global leader in 3D print. In this building alone, there's over 100 3D printers. So again, the scalability side of things has really helped us, rather than just relying on one box sat on the side. It's like a military operation at Materialise. Then go to our research and finishing lab that you've just seen on the video, and straight back to your clinic. That means you don't have to rely on being an orthotic manufacturer yourself. You can have the peace of mind of what you order is exactly what you'll get to the nearest 0.1 of a millimeter. And you can spend your time with patients, because these days, I know from a podiatry point of view, many of you are fully booked. You can't fit more people in the diary. So rather than having to make an orthotic every time, you can leave that to the experts in that world and then treat your next patient, giving you more time to help more patients. Now, there's always been a great debate over 2D or 3D foot scanning when creating orthotics. And in the past, we've always been very much focused on the 2D from a pressure measurement point of view. We feel that that's imperative when creating orthotics, because we can see exactly what goes on beneath the foot, where the excessive pressures or forces are, and then how we can actually build that into the prescription decisions. As I say, in recent years, there's been a boom in 3D foot scanning, which again is a static foot shape. And for those of you that may not be familiar with either, I'm going to give you some visual examples. So the technology that we use from a 2D point of view is called FootScan. Last year, it became the first ever gait analysis system to be professionally approved by the Royal College of Podiatry. And that's because it has been a leader in its field for 3 decades. We have over 3,000 published research papers now. And yeah, having that stamp of approval is great for the technology. But that enables us to be data-driven in our approach. We can actually determine where the forces, where the pressures are going, and how we can then bring in orthotic intervention to redistribute those. From a patient perspective, these days, there's almost that patient expectation, if they're paying to come and see you in a clinical setting, to have an assessment, to be visually shown, this is what's going on, this is what you can do about it. And to actually have data to assist your decision making is not only great for you, but it's great for the patient to see and understand, because that's half the battle in this world. And from an outcome measure point of view, you can look at someone today versus 6 months ago, side by side from a comparison, which can be very beneficial. The beauty of FootScan is you can walk a patient multiple times across the system. It will recognize every left and right foot, and we can average multiple foot strikes when we go through to the analysis, so we're not just relying on the one. When it comes to gait analysis, the word normal is always a bit of a question mark, because everyone's different. Everyone in the room is slightly different. But there are absolutely certain things that we do look for when we're assessing someone from a plantar pressure point of view. Most common thing that we look at is called the dynamic center of pressure, which tracks the center of pressure throughout the foot roll from ground contact through to propulsion. So when we walk, typically, center of pressure should start on the lateral border of the heel as the heel loads and roll in medially. It should cross the pink line as the foot supinates during mid-stance, cross the pink line again as the foot pronates prior to propulsion, and then pushing off between the first and second toes. And that's typically what we see as a normal neutral foot function. From a 2D point of view, we can roll it through. It's not only a fact of looking at the motion of the center of pressure. What's also important to look at is the time and how long the patient spends on certain aspects of the foot. We also see the ground contact time to the nearest millisecond, and we've got various different analysis screens that we can work through. 3D foot scanning, as you said, gives us a static 3D foot shape. And again, this is a new way of doing the traditional thing. We get the arch height, the length, the width, etc. But what if we could bring all of that together in one digital system? Last year with our new app, we've been able to merge the two and actually then take this directly into the orthotic production process. So not only have we got the foot shape, the foot geometry, we've got the actual function and the movement. We can really see how the center of pressure tracks through the foot, where the pressure is going, and that's great from an accuracy point of view, but again, for that patient understanding to really see what's going on has been extremely powerful. Where this gets really cool is when we can then bring both of these into the orthotic design process in one digital software. Those of you in the podiatry world, you'll be well aware of this sort of headline that you can see on the right side of the screen. But one of the most common drivers of ulceration is what we call a high impulse, where you have high pressure over a long period of time. Now, this particular example here, you can see under the first met head on the left-hand side. Not only is there a high pressure, the patient's spending more time on that part of the pressure. You can see it really clearly from a 3D point of view. When we're working with diabetic patients, we can actually utilize this data in the process, and we can overlay the patient's average impulse into the insole. So if we're actually bringing in modifications to offload and redistribute pressure, that becomes really, really powerful as well, which we'll see shortly. Now I'm just going to work through two very quick case files. This first one I've anonymized. It's actually a family member of mine. Some of you who are clients of ours would have seen this already in the past. But this individual is actually a type 2 diabetic. If we're referring back to that normative foot function, you can see on the right side they have quite a high medial pressure at the heel, also through the first and second metatarsal heads. Not only have they got high pressure through that part of the foot, they're spending more time on there. Now those little white dots are put down at set time intervals, and we should see a nice, smooth, steady distribution of those along the white line. If they start bunching together closer, it means the patient is spending more time there. Not only is there high pressure, we know he's spending more time. This individual also has hallux rigidus on the right side, quite a stiff fused big toe joint, and a huge load going through there. And again, you can see that really clearly from the 3D analysis. The impulse highlights that area of pressure over time, and if we want to dig a little bit deeper, we can also look at the zonal forces. In every half meter of pressure system, there's over 4,000 high-speed sensors, so it's important when you're looking at pressure measurement, your system has a high resolution and a high recording frequency, so you don't miss key elements. Now, if you just look at the heel as a standalone in this particular case, you can see on the left side that the heel is quite evenly distributed in terms of medial and lateral, and you've got that nice equal force distribution. Now, when it comes to things like rear foot posting, we actually look at that first 15% of the foot roll to try and prevent any excessive medial or lateral forces. You can see on the right side there really is a gulf between the medial and lateral border, and we've seen it visually, but this data gets fed directly through into some of the data-driven prescriptions. We also have a risk analysis feature. Now, we commonly use this more so in a clinical screening world or an elite sports screening world where you might have to scan 30 football players in a couple of hours, because it's great to give us a snapshot about any excessive medial or lateral forces in the rear foot, midfoot and forefoot. But it is also commonly used in the British military. Royal Marines are standard are screened with foot scan, and those that flag up as medium or high risk are fed through to the clinical team, all with a view of prevention. Now, the beauty of fits is they are dynamic data driven. So we're actually capturing that patient's foot in movement, and we're translating various principles into the orthotic design. Now, it's important to emphasize that you're not locked into any of these decisions. You have total control as a clinician. But because the system knows the patient's weight and the forces through the feet, it will suggest the thickness and density of the top cover. It will show you a suggested level of the navicular support in the medial arch. It will put it in layman's terms for the patients, because again, the patient education is key. But I'll show you more of a visual on a later slide where you can really see what that means, because we can have it to the nearest half of a millimeter. The beauty of 3D print as well is that in one device it can be flexible in certain areas, rigid in others, and it can even flex torsionally in certain directions. And because we've assessed the patient in motion, we can actually translate that data directly into this prescription. Rear foot posting, again, is one of the things that is suggested based on the data. Now, for the individual where I've just shown you that, that difference between the loading through the medial and lateral heel, for this patient it is suggested that 2-degree medial rear foot post. It's very good at what it does. We printed over 10,000 pairs across 350 clinics last year. But at the same time, if you have a preference, you want to change this, you have total control in the design. Just going to look at a slightly different example of quite an asymmetrical, imbalanced patient. And it's often this sort of patient that has more problems or pain, let's say, because that goes up the kinetic chain through the knees, hip and back. This particular case file here, patient's left foot collapses in quite sharply, and we can see a real spike of pressure through the first MTPJ. Right side, almost opposite. Forefoot varus, not really loading the first MTPJ, and we can see a slight spike of pressure through the fifth. That becomes very visually evident when we look at the 3D, also the impulse, which is the pressure over time. Now, we wouldn't need to go to this level of detail with the patient as such, but you can really see the huge difference in force through that first MTPJ. Not only does that enable us to visually see that, we can then show the patient so they can understand what's going on and then how we can assist them in the treatment pathway. Because the reality is, if we just eyeballed this patient, there's no way we'd necessarily know how accurate that asymmetry is. And of course, again, we've got the risk analysis built in. Now, some of these parameters that are calculated, such as a localized stiffness, quite difficult to demonstrate on a slide, but if you look at the one on the right-hand side, this is local stiffness. Now, in one 3D printed device, we've effectively got 5 various zones. So for this individual here, whose left foot collapses in quite sharply, we've got a more rigid border on the left-hand side, rigid medial border, but the right side has a more rigid lateral border, based on the dynamic forces going through the feet. And again, you can change this. If you wanted a more flexible medial arch, for instance, you can start to bring that down. Last year, we brought in the full integration of the dynamic 2D and 3D into the design. So now we can actually capture the foot in motion and overlay it on the insole. So here is an example of someone with a rigid forefoot varus, not really utilizing the first, and we can't really get it to the ground. As we build our design, we can overlay the patient's average pressure into the insole. We can tailor the width of the rear foot, midfoot, and forefoot. And when we're making the decisions on modifications, whether it be, in this case, a flexible Morton's extension, just sitting beneath the first MTPJ to lift it, that again makes that process far more accurate and visual from a design perspective. Let's look at a slightly different example. One of the main reasons that we bring in orthotic modifications is to offset and redistribute areas of high pressure. If we can't see that pressure, that makes that decision quite hard. So in cases like this one on the screen, where the patient's got extremely high pressures through MTPJs 2 and 3 or the central forefoot, we can add in a metatarsal dome. It will go in a structurally sound position, but you then have complete control to move it around, to optimize its location, and really look to offset that pressures. And that's 2 very basic visual examples, because I've only got a half an hour conversation with you guys. But obviously, no 2 feet are the same, especially when we move. So when we start to actually bring this data all in, we can really optimize our designs to ensure superior outcomes for the patient. In the last 12 months, where this has become particularly powerful is now the 3D scan integration as well. Not only do we have the pressure, we can actually bring that foot onto the insole. So where I was talking earlier about the navicular support, where it says normal, high, yes, very basic, but that's for the patients. We've actually got the data here as well. We can bring the apex further forward, back, up, down, to cater for your preference. So ultimately, we're bringing in the best of both worlds. Not only do we have the static foot shape, we've got the dynamic function of the foot too. If there's an argument of what's better, what if we could have both, certainly is going to be a superior combination when designing orthoses for patients. Going back to the topic of 3D printed orthotics, having worked in the traditional old school way of grinding devices and doing things by hand, there is no comparison with 3D printing accuracy. They are accurate to the nearest 0.1 of a millimeter. They are beautiful in design. There's not someone grinding it on a bandsaw, sticking things on and hoping it stays there. Your prescription will keep its prescription. They're very robust, and it's a little bit cheesy, but you can see the line going across the bottom of the devices. That's their average dynamic center of pressure. We're really trying to make it as custom as possible for the patient, because they're paying a lot of money in private world. I know there'll be people in this room charging up to £800 for a pair of orthotics. Do we want to make it look like it was made in 5 minutes? Probably not. So really important that we continue to push the boundaries of what's possible from an aesthetic point of view. 3D print is also 100% repeatable. Gone are the days of sending a phone box to a lab again and hoping that your design comes back the same as the first pair, because we've all had that problem where it doesn't. The beauty of 3D print is at the click of a button, whether it's 2, 3, 4 pairs, they will be exactly the same. And that's super important for any patients, not just the high-profile athletes, but those that specifically ask for a repeat pair. Durability is something that I have mentioned as well. Again, all of the modifications are intrinsic. Your rear foot post isn't going to bottom out. Your met dome's not going to fall off. It will keep its prescription. But at the same time, there is an element of tweaking that's possible. Lots of people look at 3D printed orthotics and think, oh God, what if I get it wrong? I'm going to have to print it again. With SLS devices, that's not actually true. They are thermoformable. They can be heated. The medial arch could be lowered. The met dome could be lowered. So despite being very durable, there is also that element of tweaking that's possible. One of the aspects that we're really quite passionate about, you're seeing it more and more these days, is the sustainability. The old school way we used to work just wasn't sustainable at all. James would order batches and batches of big blocks of plastic and half of it would end up in the bin. Phone boxes would just be sent away to be burnt, which is a bit embarrassing, but that's what happened. But additive manufacturing, 3D printing, we're building from scratch. We're building from nothing. And there's various types of materials to 3D print. Some of the ones that you might be familiar with, like a nylon plastic material as well. Our 3D print partner Materialise, as I say, they are the global leaders in what they do. They've developed their own PA12 material called Blue Sint, which is 100% recycled powder. So we're using recycled material, we're building from scratch, and also, as of the 1st of January, we're planting a tree for every pair of orthotics ordered for our clinical sites. Again, whether this is important to everyone or not, it will be hopefully in the coming years as it becomes more of a thing. But 100% of our manufacturing site is also powered by green energy too. So important to think about when you're deciding the best way to work moving forward from a sustainability point of view. Now, I'm not going to read all of these, but as I say, when I first stood on this stage 4 years ago, I think we had 10 or 15 clients that trusted what we do, became the pioneers, and that's accelerated over the last 5 years to 350 plus clinics. And it's all well and good me saying the process is great, but it's also best coming from the experts, those that have been doing this with their patients and successfully treated hundreds of the population as well. Always a challenge to try and visualize dynamic movement and 3D scanning in a PowerPoint, as you can appreciate. So I would encourage any of you that are curious, that maybe have questions or want to see it for yourself. My team are over on stand 14 for the next couple of days. If you'd like to come and learn more about how it works and how it can be incorporated into your practice, or even if you're an existing clinical partner of ours that wants to see what's new and what's coming, because we've got some really cool developments lined up for the next 12 months, please come and have a chat. But yeah, thank you very much.